Now we're ready to talk about integrals of functions of two variables. When we first talked about integration of functions of one variable, the definite integral, we had a particular meaning in mind for that. So we had an interval from a to b in the x variable. We had a curve, y equals f of x, and f of x would be the height of that curve above the axis. dx would be a little patch of length along the x-axis. And then the definite integral from a to b was the area underneath this curve, or more precisely, between x equals a, x equals b, the x-axis, and the curve y equals f of x. So how are we going to generalize that to the double integral? It should be two integrals now because it has two variables. So we call it the double integral of two variables. Well, if we generalize an interval, so if we have an interval in a, an interval in x, and an interval in y, then together we have a rectangle. Call it capital R. So this integral will take place over the rectangle R. If we have a little patch of that rectangle now, okay, it's a patch of area, so we'll call it dA to mean a little bit of area. And if we were to take the height times the dA, add it up over the whole rectangle, okay, what do we get? So we have some surface lying over top. And what we get is the volume of that solid lying over the rectangle, under the surface, and between those vertical planes. And that's what a double integral does.